quick start into Wireshark. Let's begin. I am so glad you've joined me for this nugget. Our objectives are really simple. By the time we're done, we'll have the ability to describe what Wireshark is. We'll know how to get it installed on our computers and running. And beyond just running Wireshark, we're also going to take a look at how to start a capture, stop a capture, and save a capture so we can look and analyze the data that we have collected. So let's begin with what Wireshark is all about. Let's imagine there's a PC right here. We'll label that as politically correct, or a personal computer. That could represent a Macintosh, a Linux box, a Windows box, etc. And let's say it's connected to a network. Now, sometimes we draw a network as a big cloud, but if we want to get more detailed, it's very likely that we're going to have a switch involved. And that switch is connecting lots of devices together. And then there's likely to be this little hockey puck looking guy, which I'll put little arrows on. This is a router. And that router very likely goes off to another network, and thus I'll draw the cloud. So a typical interaction might be this user at the PC types in www.cbtnuggets.com, and when that request goes out, there's a whole bunch of activity of packets that happen on the network that go back and forth out to the server and back to that PC. And if we want to see the details, the actual play-by-play for all that network traffic, that, my friend, is where a protocol analyzer like Wireshark could come in. We could go ahead and run Wireshark on this PC and ask this PC to tell us about all the data that the network interface card sees. So that means any traffic that's crossing that interface from the PC going out or in, we could go ahead and collect that inside Wireshark to take a look at the nitty-gritty details, the layer 2 information, the layer 3 information, layer 4 information, and so forth in the protocol stack. Now, there's lots of different ways we can collect this information so that Wireshark can help us look at the details of that traffic going back and forth. We could run Wireshark, the software, which is free, on this PC, and that would certainly work. Or we could run it on another computer. Let's say we have a computer that's running Windows or Mac or Linux, and it's running Wireshark. And we could have that Wireshark computer plugged into a switch port, and we could train the switch to copy all of the data that's going to or from that PC over to the port where the Wireshark device is. That's yet another way we can capture the data. This technique is usually referred to as something called port mirroring, where we're copying the content that's happening on one port, the packets, the frames, and sending it over to another port for analysis. Another option we could use to actually collect data with Wireshark would be to use a tap. And a tap would go something like this. We simply open the connection from the PC to the switch, we put in the tap, and we can plug it back to this Wireshark device right here. And any traffic that goes through the tap is replicated over this wire over to the Wireshark device. When I say this wire, I'm talking about a Cat5 or a Cat6 cable going to this Wireshark PC. So right off the bat, there's several options that we can use to start capturing, looking at this data. The most simplest option is to run Wireshark on a PC, which is what we're going to do right now. And I'd love you to join me in doing it in this demonstration. So in summary, what is Wireshark? Wireshark is software that runs on some kind of a computing device like a Macintosh, Linux, Windows. Once it's running, it takes any traffic that it can see, either directly at an interface on a PC or being forwarded with mirroring on a switch port or being collected via a tap. And then the Wireshark interface presents that information so we can start looking at it and analyzing it on a frame or packet by packet basis. Now, I have a question for you. How in the world are we going to be able to run Wireshark on a computer if it's not installed? And the answer is, it's going to be very, very tricky. We need to have the software running on a computer so we can use Wireshark. Now, here's a little secret. Some applications, when they're installed, automatically include Wireshark as part of their installation. For example, GNS3, which is a fabulous network emulator. Many installations of GNS3 include the option for Wireshark as part of that installation, so it's fabulous. Also, there are some Linux distributions like Backtrack and Kali Linux that have Wireshark already pre-installed as part of those distributions. So in those cases, you may already have Wireshark installed. If you don't, it's really easy to install Wireshark. We're going to do it together right now. Downloading Wireshark is really, really simple. If you open up a browser and head out to www.wireshark.org, there's a little download icon. We're going to select that, and then you simply choose the flavor that you want to download and install. So currently, the current stable release is 1.87. As time goes on, there'll be newer versions. And I'm going to choose and install the 64-bit Windows installer. Why? It's because I happen to be running on a 64-bit version of Windows 8. If you're, for example, on Windows XP, you definitely want to try the 32-bit flavor or whatever is appropriate for the platform that you're currently on. So if we click this, it'll give us the option to either run it or download it based on your browser and those settings. And I'm just going to go ahead and click on it and download it, and then we'll launch it to install. So in the interest of time, I have already downloaded this file. It's already sitting in my downloads folder. Let's go ahead and run the install. We're going to navigate over to my downloads folder right here. And here's the file, Wireshark Win64 version 1.87. We'll simply double click on it to launch it. And the installation, we're simply going to say yes to everything. So here's user account control for Windows 8, saying yes, I want to run it. And I'm going to say next to everything, and I agree to everything. And I'm going to install everything. That's going to include Wireshark and all the other additional drivers. So we'll simply click on next. And I want a desktop icon too. And we'll click on next. I'm going to use the default destination folder on this Windows 8 machine. Wireshark is going to use WinPCAP as one of the behind-the-scenes drivers to make it all possible. So I'm going to go ahead and say yes, I want to install it. If I was on a machine that already had WinPCAP installed, I could potentially avoid this step. But on a brand new install where WinPCAP isn't already there, I'm going to say continue, and it proceeds to do the install. So here's the WinPCAP setup. That's one of the drivers that's used by Wireshark. I'm going to go ahead and say next, and then I'll click on agree. And if you automatically want to start the WinPCAP driver at boot up, not Wireshark, but the actual driver that Wireshark uses, WinPCAP, we're going to go ahead and say yes with the check in the checkbox and click install. That's it. WinPCAP is installed. We'll click on finish. And now it's continuing on with the Wireshark installation. Now it says it's complete. We'll click on next. And if you want to run it right now, which is not a bad idea, simply put a check in that checkbox and click on finish. Then if you want to, once it launches, you can right-click the icon right here and say, I want to go ahead and pin this to taskbar. So it's really easy to find. It's going to be sitting right there, ready for you to launch. That, my friends, is how simple it is to download and install Wireshark. Now, if you haven't already done so, I'd like you to pause right now and download and install on a computer that you're authorized to do it on, Wireshark. Now, I know that many of you have already downloaded and installed Wireshark. It's ready to go. If you haven't yet downloaded and installed Wireshark and you're on a machine where you're authorized to do that, to install software, I'm asking you to pause right now and go ahead and download it just as we did together so that as we continue forward, you'll have Wireshark right there at your fingertips, ready to go. The download, install, and running of Wireshark is a piece of cake. How about starting it, stopping it, and saving a capture? The easiest way to get started with Wireshark after you've installed it is to start capturing on your local computer. So if this is the computer you're sitting at, you're tied to, I'll use Big Cloud here, some type of a network, we can go ahead and tell Wireshark, you know what, start capturing all the traffic that goes into, that means to me, or out of my network interface card right there. If we had a computer that had like 5 or 6 physical or virtual interfaces, Wireshark will also give us the ability or opportunity to choose specific interfaces that we want to start capturing on. So our next step together is to start, stop, and then save a capture. Let's do that right now. So back at our Windows 8 machine, I'm going to minimize my browser in the background, and I'm also going to maximize Wireshark. If we wanted to see a list of all our interfaces, we could click this and it brings up a pop-up. All of our interfaces are also shown right here. So on this computer, which happens to be virtualized inside of a virtual machine, I have just a single network interface card. It believes it's an Intel card. And so if I wanted to start capturing, which we do for this demonstration right now, I could either click on the interface list and then from the pop-up say, I want to start capturing by putting a check in that checkbox and clicking on start. That would start the capturing immediately. Or I could go ahead and simply select from my list the interface I want to start capturing on and then click on start. Either way, it doesn't matter. It's going to get us to the same result. So I'm going to go ahead and click on start, and it's now capturing all the data real time on this network interface. So with that running, let me bring up my browser again. And on the browser, let's go do a road trip up to cbtnuggets.com. Now, when we go to cbtnuggets.com, there's a lot of stuff that's going to happen. And just bringing up that main page, we're now at close to, well, we're over 1,000 packets and climbing. Now, here's the important part. Once we have a capture running, we don't want to leave it running indefinitely. One of our objectives was to start a capture and also to stop a capture. And how can we do that? One way of stopping a capture is going to this icon right here and simply clicking on it. This is the stop the running live capture button. So we stop the capture by clicking. We're no longer capturing any new packets. It's interesting that we have over 1,000 packets involved in just that basic conversation going out to a web page. Now, this capture also included any kind of maintenance protocols or other types of things going on in the background that PC was either generating from its network interface card or receiving at its network interface card. If you happen to be relatively new to protocol analysis, this could look like an overwhelming amount of information. However, as you and I proceed through this series together, we'll learn how to sort this out. We can set up filters for what we're going to capture. We can set up filters for what we want to display. We can control the color codes so we can highlight in various colors the things that we want to stand out. What we can also do is we can also selectively say, you know what, I'm only interested in this traffic, and we can actually save the capture with just those packets, the ones that we're interested in. And we'll be taking a look at each and every one of those options. For now, though, let's go ahead and save this capture. Now, we could do that with this save icon right here, or we could go to the File menu and do File Save. Either one would work. And I wanted to make you aware that they both exist. So here's our Save and Save As options. And let's do this. Let's click on Save. And here's what I would strongly recommend. You're going to have some amazing captures that you're going to want to keep over time. For example, if somebody came up to me and said, hey, Keith, what about this flag or that field in a DNS or in a DHCP conversation? What is that? If I wanted to remember, I'd very likely go back to my captures for DHCP and take a look so you can save them. And not only are they going to help you troubleshoot and see what's happening in your networks currently, but you can also use them as baselines and reference points to go back to. So let's do this. I would encourage you to create a brand new folder, and I'm going to call it My Captures. And then go into that folder. So it's under My Documents, My Captures. So in the My Captures, I'm going to go ahead and call this Quick Start Capture. And it will automatically put an extension at the end of it. So I'm going to go ahead and click on Save. And now that's saved. What I'm also going to do, I'm going to include this exact file in the Nugget Lab download area. So if you'd like to download it and take a look at it later, or as we continue to discuss it right here, please feel free to go ahead and grab it. So in our journey so far, we've installed and run Wireshark. We've started, stopped, and saved a capture. And our big last objective is to view and analyze that capture data. Now, I have in the Nugget Lab download area that capture file that I just created. However, you don't have to use that. If you're following along with me, which I strongly encourage you to do so, you'll have your own capture file. And here's what I'd like you to do. Whether you're using our capture file from the class that we just created that you've got from Nugget Lab, or you're using your own capture file, here's what I'd like you to do. I'd like you to identify, was ARP used, the Address Resolution Protocol? Find out from the capture file, what are the layer 2 addresses of the client where you captured that data and its default gateway? What's the layer 3 address of the client and its default gateway? What is the IP address of the DNS server that was used for name resolution? What's the IP address or addresses that were in that DNS response regarding the website CBT Nuggets? I just love the aspect of Wireshark telling us the details of what's going on behind the scenes with the protocol analysis. So we're going to use this file right here together in this video, and let's answer these questions together. The first question is, was ARP used? Yes or no? Let's take a look at the capture. Now, one way of looking for any kind of ARP traffic is to look at this column right here, the protocol, and simply scroll up and down looking for the keyword ARP for Address Resolution Protocol. However, another really quick way is to use this filter mechanism right up here. If we simply go up here and add some details about what we want to see, we could, for example, type in ARP, press enter, and that's going to show us only ARP-related protocol packets that it saw. Isn't that great? We'll have a whole entire section on filtering, but for now, it makes it a lot easier to see what's happening. Now, we could guess about what these are. Well, it says, okay, maybe this is like an ARP request that's being broadcast, and here's an ARP reply that came back. Or we could simply look down here at the details. So when we highlight a packet up here, down below, it gives us the details of that packet. So the first question is, was ARP used? The answer is absolutely yes. And here's our ARP request. And so the request was saying, hey, I really need to know the layer 2 address of 10.0.0.1. It went out as a layer 2 broadcast. Everybody on that layer 2 domain saw it, including the default gateway, which was the router, I'm presuming, at 10.0.0.1, and the ARP reply, which is right here. And here's the sender of the reply saying, yep, my address is 10.0.0.1, and here's my MAC address that you can now use to reach me in forward frames at layer 2. So question 1, done. Was ARP used? Absolutely yes. The next question was, what is the layer 2 address of the client and the gateway? Now, when we're talking about layer 2 addresses, we can still do it right here with ARP. Because in this ARP request right here, even though it's sent to the broadcast address, the source address of that ARP, which is our PC, is still going to be the literal layer 2 address. So if we open up the layer 2 information for this request, it has the source as this MAC address right here. And that is our Windows 8 MAC address. Just to confirm that, we could bring up a command prompt on this PC that we're running it from and do an ipconfig/all and scroll up to the relevant information, which is right here. And there's our MAC address. So this MAC address and this MAC address should be identical, which they are. We could have also looked at any packets coming from 10.0.0.7, and the corresponding layer 2 address of that source address would also happen to be this PC's MAC address. So great, the layer 2 address of the client is this MAC address right here. How about the gateway? Well, check this out. If we go back to this ARP reply from our default gateway at 10.0.0.1, it's going to have his source address. So in this packet, this source address right here is the source address of our default gateway, who is at 10.0.0.1, which in fact it is. And we could verify that at the command line of the host with an ipconfig to see the details of what its default gateway is. The next question is, what are the layer 3 addresses of the client and the default gateway that it's using? And we can also kind of steal that information right from this ARP request. This ARP request is, we have a request coming from 10.0.0.7. He's saying, hey, I need to know the layer 2 address of 10.0.0.1. And basically that gives it away as well. The only ARP that we're using on this network segment from this PC is ARPing for 10.0.0.1. That means the PC's address is 10.0.0.7 and the default gateway is 10.0.0.1. That information can be verified in multiple ways, but since we're looking at the ARP request and response, that's one way of verifying it right here as well. So for our first 3 questions of was ARP used, what's the layer 2 and layer 3 addresses of the client and the default gateway, we can learn all of that from these 2 packets right here in the protocol analysis. Wireshark, you rock. Thank you very much for all this great detail. Okay, our next question was, what is the IP address of the DNS server used? Now, there's a few ways of finding that information out. We could do an ipconfig from the client. It would show us the DNS server information. Or, since we're looking at the Wireshark detail, let's go ahead and clear this filter. Right now, it's just displaying the ARP protocol right here. If we want to remove that filter, we simply click right here on clear, and that will remove that filter. So let's do that. So now we're looking at all packets again. I'm also going to make the top part bigger. So here we have the packet summary, if you will, and down here we have the detail for the single highlighted packet. Let's go ahead and do a search for DNS. And there's a whole bunch of DNS action going on. The good news is that all these DNS queries right here, they are all going to the same destination address. And that is 8888. That's a DNS server for Google. Actually, that IP address represents a whole boatload of DNS servers from Google, working with some really great technologies like load balancing and Anycast regarding that address. So we have our answer to what is the IP address of the DNS server being used by this host, and it is 8.8.8.8. The final question is, what are the IP addresses in the DNS replies? Since we have lots of different requests, let's focus on this one right here. So this request right here is asking for cbtnuggets.com. All of these others, I didn't specifically ask for. I'm running a pretty plain Jane copy of Windows 8, and in the background it has all this other activity that's currently happening. And as my friend Marvin says, the packets don't lie. I mean, this activity really is happening. Let's go ahead and take a look at the response to this packet right here. So let's highlight. I'm going to click right here, packet number 29, to select the request for CBT Nuggets. I'm going to bring up this a little bit so we have a little more room. Let's go take a look at the details here. So here's the query. The query says, I'm looking for cbtnuggets.com. I'm trying to resolve that. That's packet 29. And in packet 30 right here, the response comes back. We scroll all the way to the bottom. and expand the section where it says answers, it's going to give us the information on the answer that the DNS server gave this PC regarding the IP address to reach CBT Nuggets. And in this case, it gave the IP address of 54.225.173.254. And that, my friends, is the answer to the question, what IP address did we get back from the DNS server? And all of that we learned and gleaned from the protocol analysis courtesy of Wireshark. In this video, we've identified what Wireshark is. It is the world's most popular and free protocol analyzer. We've downloaded and installed Wireshark. We started, stopped, and saved a capture, and we've viewed or analyzed that capture. Not just looked at the data, but actually gleaned information from the data that was there. Real protocol analysis. Your homework assignment, should you accept it, is really, really important, and it's really simple. I'd like you to download and install Wireshark. I'd like you to start, stop, and save a capture. Now, when you start your capture, go ahead and open up a browser while that capture is running and go out to cbtnuggets.com and then stop the capture. And then I would like you to answer those questions regarding, was there ARP involved? What are the layer 2 and layer 3 addresses? A little bit about the DNS from your own capture. Now, you might be saying, well, Keith, I already did that right there with you, brother. Every step of the way, I paused, I did it already. Your homework is already done then. I have had a lot of fun. I am so glad you joined me for this video. I hope this has been informative for you, and I'd like to thank you for viewing.